And now I'm going to run it. Let's see, comments. So if you want to make a comment, there's this thing called the compiler. And so what the compiler does is it runs through, if I were to have like 50 lines of code, that did something, of course this isn't going to do anything, that did something, what the compiler would do is it would go line by line, and it would check every single line and run each line of code like that. And so that's why it's so key sensitive, is because the computer's reading what you do and it only understands a certain language, which is why it's called a language. And so what that symbol right there, the percent symbol, what that means is basically don't run this line of code, just forget about it. Well, not this line, everything after that it won't run. So I could do, let's say x equals 7, and then put something after it, and it just won't run whatever after that. Here, let's see if it does it. So I'm just going to say hi. Then I'm going to save and run. Yeah, and you always want to add directly to the load path. And see, it prints out 7, but it won't run this. And so that's just what that does. It really doesn't change your code at all. It just makes it easier for you to read. And so I said x equals 7, so that's what I was going to get into next. So defining variables, it's fairly easy for Octave. Well, I say it's easy, but I have experience with it. But it's more difficult because you'd have to define the type of variables, but we don't have to do that, I don't think, ever. So I'll just use x. So you can make it whatever you want, as long as it's not a variable that is preset like max. I couldn't use that because, as you see, if it pops up in this little window right here, it's one that you can't use basically. And so that just tells you that you can't use it. Pick another one. So I'm going to call it x, and that's obviously not used. And now x is different from lowercase x, so it is key sensitive. So I'm just going to call it x, and so this is defining a variable, and it's really easy. I'm just going to space and an equal sign. You don't have to do a space and an equal sign. It'll do the same exact thing. In fact, I'll show you. I'll just do x equals 7 again, and then lowercase x equals 7, and it won't make a difference. See, same thing. It just looks better with a space, and that's why most people do it. So I'm going to put a title on this because it's bothering me. Sorry. Let's call this test. And then I like to put spaces in between things because just to me it looks better, but you don't have to. Again, the compiler will just skip over spaces and it won't really mess with your code at all. You always want to put clear because it clears previous inputs, and it basically, if you don't clear, sometimes it'll mess with your program. So always clear. But yeah, so that's just how you define a variable. And a variable can be anything. It can be a number. It can even be another variable. So I could say x equals 7, lowercase x equals 7, and then, well, let's just not make it confusing. I'll do y equals x, and then x will equal 7, or y will equal 7, which is what x is. Yeah, so y equals 7. You can do it that way. Now, if I didn't want it to display the, sorry, my space bar doesn't work. If I didn't want it to display the x equals 7, I could just put a semicolon after it, and that's all the semicolon is. If I don't want that to show up in the output window right over here, I can just put a semicolon after it, and it won't. It doesn't change anything in your code other than that. So again, it's just for you, the user. It's not really for the computer at all. Where was I at? Defining a variable. Okay, so a variable can be a number, pretty much. Now, we're only going to use it as numbers ever, but you can specify that it's not a number by doing this right here. By doing this right here, you put a parentheses, and then you put a quotation marks, and then you can just type whatever phrase you want in words. You can even put numbers in there. And so I'm just going to say hello world. That's a famous coding thing. I don't actually know why. And then you have to end it parentheses, end it in quotation marks, end it in parentheses. And then if I run that, yeah, y will equal hello world. And so That's a little bit different. So that's a string, I believe. Don't quote me on that. As opposed to an actual integer number. And so basically that's just another thing you can do with defining variables. Let's see. Now, we can define variables, but we can also define matrices, which works a little different. So I'm just going to call it matrix, and that's right. Variables can be any length. I think up to like 32 characters, which you never want to do. So a matrix is a little bit different. And again, all of this putting parentheses around stuff is just for the computer to recognize what you're doing, because the computer is stupid and it doesn't know what you want it to do unless you specifically tell it what to do. So defining a matrix, you have to put a bracket around what you want to define. So this is just an empty matrix right here. I don't think it'll give me an error if I do that. Let's not show that. So yeah, it's just a 0 by 0. So there's nothing in it. That's what it tells me. It's an empty set. Now, there's vector. So there's like rows, and then there's column matrices. And you can have, let's see, a row would just look like this. You would define it like this. Let's just make it 1, 2, 3, 4. Oh, well, I messed that up, didn't I? 3, 4. So you got to put a space after each one, kind of like when you're actually typing. But my space bar doesn't work all the time for some reason. So basically, this will print it out in a row, just like I have it printed out. So I can click run, and yeah, it'll be a row. Now, there's two ways to make a column. Let's make another one. Let's call it matrix 2. I can actually type my letters like they're a column. So I can 1, and then I can enter space over. You don't have to space over. I just like to space over because it looks neater. And then I can do 2, and it'll actually remember it, which is really nice. Then I can do 3, and then I can do 4. And that's going to create the same thing, but it's going to create it in a column. So let's run that. And as you see, it's in a column instead of a row. Now there's also another way to do it. I don't like doing it this way. It's more confusing to me. Let's just do it with another matrix. Yeah, I'm just creating all the matrices today, huh? And let's hide these. Again, that's what the semicolon is for, hiding things. And I'm going to call it matrix 3. I know I'm being really creative with the names here. What in the world? Get over there. Matrix 3. And let's call it, oh, and by the way, you don't have to do the commas if you're doing a row. I think you can if you want to. Here, let's test that out. I think it'll give you the same thing. Oh, it's going to give me an error. Comment. Because that's not defined. That's why it would have given me an error. Well, I just clicked 5. I didn't click shift. Oh, well, I have it hidden. Wow, good job, Luke. Yeah, so it'll be the same thing with the commas. If you feel more comfortable putting them there, you don't have to, though. I'm just going to keep them there because I'm too lazy to put them away. So another way that you can do columns is if you put 1 and you want to start a new column, you can put a semicolon, and then you can type the next number, and then you can put a semicolon. You can type the next number, and you can put a semicolon. And that just basically every time you put a semicolon, you're telling the compiler, which is a thing that goes line by line and reads what you're doing, to start a new line. And so we're just going to do that, and it's going to create this. It's going to be identical to matrix 2. Yeah, so matrix 3 right here and matrix 2 are identical. It's the same thing. This one just, to me, looks nicer. This could look nicer to you. It all depends. And so those are all just one-dimensional, as Dr. Bay says, vectors or matrices. And so now we can create a 2-dimensional matrix. I'm just going to call it matrix 4. You know, I'm just going to delete all these. I don't like the way it's looking. That's another thing. You know, it's all about how you want it to look. Oh, I misspelled matrix, didn't I? How did I even manage to do that? Max trick. Matrix. We'll just keep it matrix. And so this is the way I like to do it. I could do 1, 2, 3, 4, and then I could do this. I could basically enter underneath, and this will create a new row. And then I can type 5, 6, 7, 8, and then I could go down again, and I can type 9, 10, 11, 12. It's starting to get a little out of line, but it still means the same thing. And then I could end it. And if I print that out, it'll print it out like that. Now, I could also do it the same way. I could do it like this. Stop doing that. Where I could do the, what do you call it? I could do the semicolon after each one. But again, I just like the look of the other one better. But you can do it this way if, your heart was set on it. I don't know why it would be, but, some people are weird that way. Let's just type this down. And this should be the same thing as matrix 2. And it is. So those are the same exact thing. Matlab will read them as the same exact thing. The compiler will read them as the same exact thing. One of them just looks better to me personally. And so that's the one I'll choose to use. Now, oh, that's not the backspace. Another thing that we can talk about is each one of these numbers is called an element. And so I can call a certain element of a matrix. And it works like this. I can say matrix. I don't have to say matrix. That's just the one that I've defined. So that variable is matrix. And then I could put basically the sort of think of it like a coordinate plane, the x and y locations of the element. And I'll show you what I mean with an example. So if I wanted to do 1, 1, that would be the first row, first column. So it'll print out to me basically the first row, first column, which should be 1 of the matrix. And it does. The answer is 1. Now, an interesting thing, if I didn't want that to say answer, what I could do is make it a variable and just call it element. And it'll do the same exact thing, except answer will say element. It means the same thing, it just looks better to me again. And element would be a variable, and that variable is a certain element of a matrix. It all kind of stacks on itself. So see, it says element equals 1, which I like better. Now, if I were to say 1, 2, it would be 2. And now if I were to say 2, 2, it would be 6. And it just kind of goes like that on a coordinate plane. It's kind of easy if you don't want to do the whole entire matrix to just pick out little bits like that. So now another thing that we can go over is variables. The way Octave does it, it does it line by line. What I already said, the compiler does it line by line. So if I say, let's say variable, just because I'm really creative with names today, variable equals 1. And then I want to say variable, later on I want to say variable equals 2. Okay, then I want to say variable equals 2. Basically, any code that was in this line here, I'll actually make it a line. I'll comment it out so that Octave doesn't do anything about it. Any code, I'll do it nicely. Any code that was in between this area here or on the lines would basically use variable as 1. Any code after it would use variable as 2. So basically what Octave does, if I were to make this, let's say computation 1 equals variable plus 1, then I would get 2 basically for computation 1. But if I were to write it down here, computation 2 is equal to variable plus 2, and I can again put spaces in between these if I want. It's whatever looks best. So computation 2 equals variable plus 2, I should get 4 as the answer. And so basically what the compiler is doing, it's running down test, well, it doesn't actually read that, so my bad. It'll clear everything beforehand, and then it'll say, all right, x is equal to 7, but I'm not going to show that to the person that's on the computer. Y is equal to the string hello world, but I'm not going to show that to the person on the computer. Matrix is equal to, and then it'll read that out. Element is equal to matrix, the second row, second column of matrix, but I'm not going to print that out. Variable is equal to 1. Okay, so computation 1 is equal to variable plus 1. That's equal to 2. Well, now he changed what variable is, so variable is 2. So now computation 2 is equal to a variable plus 2, which is 4. And so that's how it does it. Me making this 2 will not change this right here. It works linearly, top to bottom. So let's go ahead and let's run that. Let's clean this up a little bit so it's not printing out 20,000 things. Let's run that right there. Yeah, so as you see, variable is equal to 1, so the computation is equal to 2. Variable is equal to 2, computation 2 is equal to 4. And that's basically, whenever you redefine a variable, it basically kind of changes the variable. And now that linear thing I was talking about changes just a little bit in loops, because it'll basically, if this was a loop, actually let's go ahead and do that. I wasn't going to get into loops, but let's just do that. So if this was, say, a loop, so let's say if variable, I'm not going to get into loops today. I'll do that another day. Yeah, so I'll make sure I explain that next time. I hope this was helpful. If not, tell me what else I need to do. I'm just saying all the time. See you next time. Adios.